reduce what it is. So the idea with these questions, let's see. It says the following sketch shows the graphs of f of x and g of x from 0 to positive 180. So what we need to take note of is all these questions, right? You see, asking for a period, amplitude, coordinates of A, B, coordinates of P and Q. One word, theory. You see, it's always gonna go back to your theory of what you may call of trigonometric graphs.
Yes.
For example, with all these graphs, right? We all know that with a trigonometric function, the format that you can always look out for is this. You'll have A, and then like a trig expression here, and then you'll have like bx minus p plus q, of which these letters here, A, B, P, Q, these all what you may call, they all mean something specific. See, like for example, A stands for amplitude, of which all that, you know, it's work where if you like go through it like once or twice, it then sticks. You see, B is the frequency, of which the frequency is equal to 360 divided by the period. You see, this is already like a formula. You see, where if you need, you can use it. If you need frequency, you can use it. And then P is the vertical shift, meaning, you know, shift from top to bottom, vertical shift, and then Q is then the horizontal shift, horizontal, where? Horizon, oh snap, I forgot the T, tau shift. So as long as you know these things, right, it gets easier for you to like answer trig questions, because already if you're looking at something like cos 2x here, you are seeing here that the item directly next to x, it represents the frequency. So you know here the frequency is a 2. And then here, looking at where the 3 is, you can see that 3 here is representing the amplitude. And then looking at where -1 is, it's on like the far right. So it's representing a vertical shift.
Okay.
Oh, wait. Good Lord. Just like vertical is from top to bottom. So that's for Q.
Yeah. And then P is for horizontal.
Yeah. So yeah, anything that's fishy, yeah, we should just not leave it alone, you know. But then yeah, that's, yeah, so this is fine. So P here is going to be the horizontal shift, which is a shift from left to right, and then Q is going to be a shift from top to bottom. So as long as we know that, we are good to go. So let us go now. So for example, here they want us to write down the period of F. So if they want us to write down the period of F, then we should just use our frequency formula, you see. Frequency is equal to 360 over the period. Just wait. We like it. So here we know that 2 is equal to 360 divided by P. So if you solve for P here, you just cross multiply. P times 1 is 2. I mean, P times 2 is 2P. 1 times 360 is 360. And then divide by 2 on both sides. P is 180.
Yeah.
You see? Nice. Yeah. So for G, I mean, for the amplitude of G, it's also based on theory, you know? The amplitude there is just a 3, because we know that the equation is going to give us that. Now,
Liva, you get the 2 from the cos 2x, right?
yeah, because you see the 2 is the number that is directly next to the variable x, because there's a variable x and then there's be directly next to it. So the number that will always be on the left of x is always the frequency, you see. Because if you look
Yeah.
at it nicely, right, what you actually have here is f of x equal to 1 cos 2x plus 0 plus 0, you see. That's how we know that the amplitude is a 1, the frequency is a 2, there is no horizontal shift, and there's no vertical shift.
Okay. Yeah. Got it now.
So with these questions answered, right, the next thing we would be asking, the next question that's being asked here, where we're going to need to use our theory also, is they're asking for, what are they asking for next here? The next thing that they're asking for, if you look nicely here, is certain coordinates, of which those coordinates, as long as we know how our theory works, we're able to work out those coordinates easily. So the fortunate thing also is, I mean, for trigonometry, you will find these basics in the trigonometry playlist. So, yeah, let's see. So, where's that thing now? So moving on, right? It says here we have, they want us to write down the coordinates of A or B. So the idea is, if you look at where A is, right? This is from 0 to 180. A is a point on the graph of G. You see?
Yeah.
And then do you see that according to this is telling us that the graph of G, right, is a sine graph. So if you think of it nicely, this sine graph from 0 to 360, if the equation was y is equal to 3 sine x only, it means up here would be a positive 3, down here would be a negative 3. And then this would be 0, 180, 360. See, this is what the equation would look like if the equation, this is what the graph would look like if the equation was just sine with 3 in front here, 3 sine x. Do you see?
Yeah.
Because this is what's showing us that the amplitude is just a 3, because from the point of rest going up, going down again, this is 3. And then here again, from this point all the way down there, that's also a 3. Fine. Now the idea is, this is telling us that this same image was moved 1 unit downwards, you see. So if this same graph was moved 1 unit downwards from 0 to 180, we're going to be seeing a picture like this one, because instead of cutting the x-axis at 0, it's going to cut it down here at -1, you see. So we automatically know that according to this new image, this point here is a -1. So instead of going all the way up to a 3, this would now only go up to a +2, because from here it has to go up 3 and then come back down 3. So I mean, this coordinate here, we can see it's just 0, coordinate -1. This one here, we can see it's just 180, coordinate 0. Do you see?
Yes.
Yeah. So you can already see right in the middle of 0 and 180, you're going to have 90 over there. You see? So we know that this point here, it's just x value 90, y value +2.
Yeah.
Yeah. So with these kinds of questions, yeah, that's the idea. Always try and like reverse engineer them based on like a standard sine graph. Just try and draw a standard sine graph and then just try and see, okay, fine, what happened from what is standard to this? I mean, like you could have even started off with like how a standard graph will have like an amplitude of 1, but then this has 3. So you from 3 to 3, or 3 to -3 rather, and then you move it whichever way you need to move it. So that sorts out A. See, A is just 90, coordinate 2, 90 degrees, coordinate 2. B, we would do exactly the same thing for the graph of F. So let me just copy this image again, and then we can discuss certain things about the graph of F. So with the graph of F, it's a coarse graph, you see. So what we would need to think to ourselves is, with this coarse graph, firstly, like always, as long as you're comfortable with what the standard graph looks like, then you have a lot of ammunition. What I mean is, firstly, a very standard coarse graph, right, has the equation y is equal to cos x. Now, this will look from 0 to 360. We all know that it will look like this. It goes up, down, and then there. And then we also know that this will be like a 90. This will be like a 270. In the middle here will be like a 180. This here will be a 0. This is stuff that you can safely say you know, right?
Yes.
Yeah. And then up here we know it's a positive 1. Down here we know it's negative 1. This is a standard graph. Now, what we know is, if you are going to change stuff here in the equation, it's going to affect the image. Now, the one thing that we can already see here is that, firstly, in terms of the theory, right? Frequency is, if you can think of it as a definition, right? Frequency. Whoa. Your frequency. Why does this look so weird? What did I write it as here? Frequency. Oh yeah, I'm busy putting A. I was like, bro, something is off, but your brain can't see it. Frequency. So if you can think of a definition, right? Frequency is basically how many complete graphs in a space of 360. That's what frequency is. So for this image, you can already see that you have one graph in a space of 360. So the frequency is 1. However, the moment your frequency is at 2, it means that in a space of 360, you'll see 2 complete graphs. So you'll see one, and then after that, you'll see another one, you see, between 0 and 360. Meaning halfway through, you would have like a complete graph, you see. Between 0 and 180, that's all you will need for you to get a full graph, which is the image we're seeing here, you see. From 0 to 180, we have a full graph. Now, because the frequency here, it would be at 2, you see. So if we're looking at that, we can just use our theory also. So we already know that if all these get halved, it means that initially the turning point here would have been at 180, right? But then if you halve everything, the turning point would be at 90, where x is a 90. However, I mean, you're just shrinking it, you see. You have not changed the amplitude. The amplitude is still a 1 here. Here, the amplitude is still a 1. So it's still going to go up to positive 1. It's still going to go down to negative 1. You have just shrunk the graph. You have shrunk it because you have increased the frequency. Increasing the frequency, you can see you have more of it in a space of 360. You have 2 of it. So it's just going to shrink your image, right? Because remember, your trigonometric graphs, they're just periodic. Periodic meaning they just go on and on and on. Meaning what you see from 0 to 360 is just a portion of a long thing that goes on forever and ever and ever and ever and ever. So for a coarse graph, they normally just show us this image from 0 to 360. So if they alter like the frequency, then obviously, I mean, as you already know, it just means that our lines just get closer to each other. And then it's like, you know, it's like you're shrinking the thing. So here we know that B, the X value is going to be a 90. The Y value is going to be a negative 1, because it's going to be 90 degrees, but it's still going to be down there. It's going to be a negative. X is negative 1.
Yeah. Cool.
Perfect. So that is for A and B, frequency and period. Fantastic. We love to see it. So yeah, with what